Today we're joined by Claire from Bekaert that runs a big part of the fiber reinforcing picture for them. We talked a little about fiber reinforcing in concrete from the general standpoint, something that I actually think every firm needs to be using. In my limited sample size, it's been 50-50. But there are many types, and the biggest part of our conversation is steel macrofiber and all the good it can do. Durability, crack management, and more. I actually just had a conversation with Tyler Lay about this and this style of reinforcement. That episode is maybe a month away, but really, if you don't use this, you need to be. And if you're looking for an episode to learn the basics, we've got one for you.
The Structural Engineering Podcast.
Thank you so much for having me. I'm really excited to be here. So my name is Claire Gandee. I am currently the Senior Technical Manager for the Fiber Reinforcement Group with Bekaert Corporation. We're actually a Belgian company, but our U.S. headquarters are in Atlanta, which is where I'm based. And I also head up our business development. So I'm working directly with both owners and structural designers to understand fiber reinforcement for concrete, how to use it and when to use it and how to specify it and drawings and specifications and so on. My background is in structural engineering. I was a practicing structural engineer for the early part of my career. I worked at Walter P. Moore, and during the downturn found my way not working at Walter P. Moore anymore. and found my way into technical sales. And I was working at structural concrete and post-tensioning software called Adapt. There's some debate in the industry whether it's Adapt or Adapt. We can leave that one for the listeners to decide.
Yeah.
But
always called it Adapt.
That's right. I always called it Adapt. So agree to disagree, Zach. But but I was there for 9 years, and I headed up our technical sales team, and then finally I was the director of sales there by the end of my tenure. So I've had a lot of exposure to lots of things, on the design side from structural concrete software, and now really digging my heels in on the concrete side. I think I'm concrete for life after my now 7 years here with Bekaert in fiber reinforced concrete.
Wow, that's quite the career. That's really cool. I always find it interesting every time we interview someone to hear how they got from, school to where they're at today. And I mean, that's really cool. Walter P. Moore through concrete or Adapt, whichever way we want to go with that. So yeah, today we're talking about fiber reinforced concrete, something Max and I we know a little bit about. We specified it once or twice, but something we want to dive into way more. So to start us off, where is it typically used when people are thinking about where should I apply or utilize fiber?
So in truth, I find that there's a lot of confusion and mystery around this. But in my side of the business and here in North America, the vast majority of what we're doing is in concrete flatwork, specifically slab-on-grade, slab-on-composite metal decking, concrete pavement. Those are the biggest applications that we're used in. Now, I have other divisions of my team who are doing precast work, infrastructure work. One of our other large global segments is in underground, so things like tunneling and mining. So, these huge precast tunnel segment elements, right? These are going in. Those are now predominantly just fiber reinforced. There's no rebar in those. So all these, tunnels that are going in tens to hundreds of miles long in some cases in the UK, in Europe, in the US as well. That's actually a really strong market as well.
So I know, even though Zach said we know a little bit about this, I don't. So just setting the stage of, what is steel fiber reinforced concrete, can we get a background of what is the groundwork for what is occurring when we put steel fiber in concrete?
So I want to kind of start out by saying that there's a lot of different types of fiber reinforcement, and they have different implications of what they do or don't do to a concrete mix when they're included. So on the steel fiber side, I'll give kind of take a quick step back to explain some of this. So what I didn't know when I was in consulting, and even when I was in school, I didn't learn anything about fiber reinforcement, but there's ASTM categorizations for all these different types of materials. ASTM categorizes, it's A820 if you wanted to look it up, categorizes steel fibers type 1 through type 5. And the types are the types will indicate how the fiber was manufactured and how it should be used, plus minus. Types 1 and 2 are by far the most common for use in flat work. A type 1 is cold drawn steel. So just like the name implies, right? It's a round, wire rod, raw material. It's drawn until it reaches a certain diameter and will then have a certain tensile strength and is configured in different ways. The fibers that I work with are straight with hooked ends, but there's other different shapes, out there. Type 2 fibers is called a slit sheet fiber. So as the name implies, it's where you have a manufactured sheet of steel and it's chopped up. So that's going to have more of a rectangular cross section, whereas the type 1 fibers are going to be round, circular cross section. And since the originating product, the sheet steel, is a lower tensile strength, the type 2 fibers are correspondingly going to have a lower tensile strength. So the way that you use a type 1 steel fiber is similar but different than a type 2 steel fiber, for example. So when you use a type 1 steel fiber, so the product that we have is called Dramix. That's going to improve post-crack flexural behavior. What it doesn't change is modulus of rupture, modulus of elasticity, or compressive strength, right? So those parameters of your concrete are going to stay the same, but what's going to happen that's different is post-crack, which, by the way, is the same thing as what rebar does, right? That's exactly how rebar behaves. Even if you add a number 11 bar to concrete, it doesn't change modulus of rupture. So on the type 2 side, just being clear about that. So type 2 fibers do not, even at very high dosages, those are the ones where you might see, 65 or 66 pounds per cubic yard dosage, which is pretty high for flat work. And even at those high dosages, you wouldn't expect to see a change in post-crack flexural behavior. And in fact, it's not counted on in design. So with a type 2 steel fiber, it's actually a plain concrete elastic design more often than not. Whereas with Dramix, we might be at a third of that dosage. Let's call it roughly 20 pounds per cubic yard, up to maybe 40, 45. We are seeing a pretty significant change in post-crack flexural behavior and toughness, residual strength gain. And as a result of all of that, we can actually optimize slab thickness. And that's one of the reasons why these fibers are so effective and used so much in highly loaded industrial scenarios. So automotive, manufacturing, and so on. That's where we get a lot of value add in using a type 1 steel fiber.
Actually, can you give me, so I can picture this, the volume in my head, like 70 pounds per cubic yard? Is this, if you took a little handful of your concrete mix, would there be 1 or 2 strands in there?
You would definitely see them. Okay. Absolutely. More than 1 or 2. If you had 70 pounds per cubic yard, that's a lot. And you would definitely, if you were holding them in your hand, I can send you guys some pictures later, you definitely see them. 100%.
Okay.
Yeah.
And, length. Another thing, just so I can visualize this helps me think about it. But are these 2-3 inch?
Yep. So they're going to vary in length. So for my colleagues who are doing underground work, we have 30 millimeter fibers. So yes, we're a Belgian European company, so metric, but also just generally speaking, fibers are often denoted in metric just because the length, right? How do we break up inches in the decimals? It doesn't make any sense. So a 25 or 30 millimeter fiber is pretty common for some underground applications, but in flooring, the most common length is 60 millimeters, which is about 2.3, 2.4 inches. Yeah, exactly. It's this. That's exactly right. In fact, I happen to have some right here. I'll show you.
Yeah.
I'm going to put it, hopefully you can see. So this is a 60 millimeter fiber. Right here.
The number 60 is big. Yes.
Millimeter. Yeah, I know. Metric system just blows our mind. A little bit about 2.25 inches.
Okay. How would you describe that shape? Because that was not just a flat piece of metal.
No. So this one, so the Dramix fiber, so this was really one of the first products that was brought to market with this shape. So I guess I'll try to hold it up so that you can see it. So it's straight through the center and then it has hooked ends. And Dramix has a few different configurations. Within the product line, we have different brands which have different hooked ends. So the more hooks, the better the anchorage and better the performance. So, depends. And that's really our job in-house at Bekaert is to try to, help folks and guide them to what's going to make the most sense, both defending the technical side of it as well as the commercial side, right? It has to price out. And so that's where we can kind of look at different options, and based on the criteria of your project, okay, well, I think we should go this route because of this.
So I thought today would be really fun to frame the whole conversation now that we kind of have the baseline of what the fiber looks like and lengths, and now the language of how much you might put in per yard, kind of going through a story of a project. And one we had talked about before was a project that you did where contractor A and B on the same exact project, because it was absolutely huge, decided to go different routes.
Yeah.
Would you mind kind of walking us through what the initial thoughts were?
Absolutely. So this is a confidential data center project, so I can't give specifics, but happy to share the story. And I think it's a great example of the power of fiber reinforcement. It also really well describes, I think, a very human experience that people have when we go to change something as fundamental as slab-on-grade reinforcement, because it's actually a very emotional reaction that a lot of people have, despite what we might want to name it something else. So I'm on a huge campus. We were brought in to this project through the self-perform team of a GC. It was one of two GCs involved in the main building scope of this project. So it was so big that there were two GCs doing complementary but different work on the same site. And we had history with the self-perform team. We'd done many projects with them before. And they had actually, it's kind of interesting, they had tried to bring us in at earlier phases of the project. But again, because I would say the primary hurdle that we face with bringing fiber reinforced concrete into a project is that people are not familiar with it. And therefore, it makes them feel nervous. And so they just shoot it down for various reasons. But when, over the course of many cycles of, let's call this person, an internal champion who really saw the value, had worked with the product before, understood why it would bring a tremendous value to this project, they finally got the question. Somebody said, you guys, we're looking at the schedule. We're really struggling with schedule. How can we speed this up? And so he raised his hand and he said, I have an idea. Forget the fact that he'd already mentioned this like 5 different times in previous meetings. But he basically said, look, the fastest thing we can do to expedite the slab-on-grade execution is to remove the rebar. And we can do that with this really high-performance steel fibers that I've used in the past. So the owner got involved, and there were lots and lots and lots and lots of questions. We had tons of calls. We sent testing information. We explained the different protocols as to how the strength is characterized, right? The different standardized tests that are involved, and what are the implications on the mix. Now, we were brought in because of speed of execution, but one of the other benefits that we could provide is reducing carbon emissions, which, of course, at the hyperscale level, these data center owners really care about that, right? Because those facilities are so energy demanding and water demanding that being able to offset that in their construction is really interesting and valuable to them. So we were able to demonstrate the speed of execution, but also the CO2 benefits. And then all of a sudden, things are looking a lot better. We did a couple of mock-ups because they were very curious. So some of the biggest mock-ups I've ever seen, we did an 80-foot by 80-foot mock-up, which is in the concrete world, kind of big, and it went fine for the most part. Now, one of the challenges that we were working through was, for example, the timing of saw cuts. So I've been on plenty of conventionally reinforced slabs where the saw cuts don't look that good, right? Timing is everything. So that was something we had to work through with the flooring contractor, the GC, and the owner, and just kind of convey all the best practices, lessons learned. So long story long, they went with that solution.
Yeah.
Hooray.
Yeah.
Now, it took a little while for that to happen. Meanwhile, the second GC on the site, we were also talking with them and their design team. We'd also provided solutions, but they didn't have that in-house experience. They hadn't worked with us before. They weren't as familiar with it. And they ended up, even though they also did a mock-up, they ended up deciding to stick with the conventional approach. And I thought, this is going to be really, really interesting to have this exact same site with the same owner with a rebar option, a single layer of rebar, versus a fiber reinforced solution, and just see how they go side by side. And the way that that played out was actually the GC that we were working with started on slabs and flat work second. They were later to the game just as far as getting slabs down. But once they started, it became really apparent how much faster they were able to move.
I have a
To the point.
question.
Yeah. Go ahead.
The contractor that decided not to use this, since we will know what the final outcome is here, what decision led them to say, let's just do rebar?
So we had come to learn, right? There's multiple factors that go into any person's decision-making process, right? So we're talking about a huge hyperscale campus, which in and of itself implies a pretty significant risk for the general contractor. I recognize that. And what we've come to find out since then is that this GC had a previous instance where things didn't go well for that same owner, and they got dinged, and they really they just wanted to play it super safe. Okay, totally human, understandable. I mean, I can't say that I would do anything different in their shoes. However, just in this particular example, as slabs started to go, and this other GC was like, oh man, and then all of a sudden we're starting to, hear some commentary around maybe the owner was questioning, like, why didn't you guys do this again? But, this is business. Business is all about, seeing opportunities, but also mitigating risk. And so, again, I don't want to cast shadow on them because I understand now why they made the decision that they did. But what's great is that we are having more conversations with that GC about other sites, right? I think that they've now seen and understood that this is something that's very doable. And we actually bring a lot of resources to the table to try to support the process and make it go as well as possible. But it was really noteworthy in that particular project, just what a stark contrast it was, and how the owner was also involved in kind of thinking like, why, what's different here?
Yeah.
Exactly. So, yeah, so that I think that was a fun one, so to speak, if we're calling that fun.
I think we have a very hard industry to move at all, and so it's great to have this scale of a project and just the two versions that we have available to us, essentially, side by side, and we can compare them, actually.
That's right, and we're just changing hearts and minds one project at a time.
So thinking like an engineer, my first thought would be, if I were to be on that project, I've now specified a slab-on-grade and a thickness and a rebar mat. And now someone's coming in and saying, we're changing it. We're going to put fiber in that.
Yeah.
Is that, how do I go about that? Is that just something that the supplier sends a cut sheet and says, this is the equivalent replacement? Is it somehow in one of our code books that we use that says this is the equivalent replacement with fiber? Like, what's that first step? Because I'm sure, as Max and I'm guessing, Max, I'm going to talk for you here. I'm thinking the same thing. I'm like, do I just put concrete with fiber and someone else figures it out?
Oh, no. Don't do that. Okay, such a good question and such an important question. And the truth is that it's going to differ based on what phase of design and drawings you're at. So let's use the example that you said. You've finished your design process. You're through 100% CDs. You've issued IFC, and the contractor says that they would like to use an alternative, right? So in that, I know, right? Don't be afraid. It can be okay. So in that case, what you should hope to receive is not just a cut sheet. That's absolutely unacceptable, in my opinion. You need to see calculations, and ideally there should be a pretty significant and robust calculation to show at least flexural equivalency. That's the basic starting point, right? Because the vast majority of slabs are governed by flexure, in my experience, okay? So if we're just saying you have an 8-inch slab with a single layer of, let's say, 4s at 12 or 5s at 12, then can we provide a flexural equivalent to that? Now, I know with my steel fiber reinforcement that we are for sure going to improve punching shear. I have never once seen a slab fail in punching with my designs, so I'm not worried about that. That's actually one of the ways that we really, really increase strength is in punching shear. And so we would want to provide to you enough justification to show that this is an equivalent solution to what you have designed. Now, that's in the absence of, let's say, the me of the fiber provider being able to speak directly to you. And that's something that I always push for. So when a contractor calls us up and says, hey, can you give us a flip on this? Sure, we can. However, what I really want to do is talk to the structural engineer on your project. I want to understand, what's your subgrade modulus? What is the jointing? What is your primary concern? What is the loads? What type of forklift do you have? What is the racking? What is the base plate size on the racking? What's the spacing? What else is it that's going on this project, so that we have an in-house software that's a yield line based solution, which I know nobody in structural engineering really uses yield line. We probably learned about it in concrete class sometime in school, but I don't remember. But that's the basis of our designs, is all yield line based. And we would run a true and pretty robust calculation in that case. So with that, then you're seeing some really, really thorough calculations. So whether it's uniform loads or wall, line loading or forklift loads or truck loading or whatever the case may be. Ideally, you're receiving one of those two things, right? Either a pretty robust, full detailed, true analysis or a flexural equivalent. And based on that, you can start to snuff out, like, does this make sense? Am I seeing something that really doesn't add up or not? And this is actually something where I think the vast majority of fiber manufacturers and the technical people that work for them are trying to do a good job. They're trying to be honest. But I have seen some things where I'm like, are we really comparing apples to apples? So I have also offered to people, like, listen, if you get a request and you're not sure, like, you can send it to me and I will just put at least eyes on it, just knowing, because, right, if you take a slab and you check a load right at the center of the slab panel and it works and you say, like, yay, great, I've done it. That's not really a true representation of what happens in an industrial slab-on-grade, right? You have joints, so we need to check, how does the forklift load transfer through the joint? Do I have sufficient load transfer? Is the slab strong enough if there's a free edge termination at the truck dock and the truck is coming in and out of the building? Is the slab designed for that? Do I need extra rebar right there? And so on and so forth. So just making sure that all of those different configurations are being checked. That's something that I've provided. Now, listen, I don't want to get in the business of checking other people's fiber designs, but, with relationships that I've built up over the years, folks will sometimes run things by me and I'll just say, maybe you want to ask about this or maybe confirm about that. And if it's good, I'll say as much. Look, this looks reasonable.
Yeah.
It's okay. So that was a very long answer to just a part of your question.
Yeah. So early, if they've done it before and they feel confident with it, are they specifying then per cubic yard in
That's
their
right.
drawings?
Yeah. So that is what, when I started at Bekaert, that was really my biggest goal, was to get in with structural engineers directly and say, instead of having this come through to you with extra work at the end as a conversion, why don't we look at and identify projects early on and say, this might be a good candidate for fiber reinforcement. And then we can work together on the design. And then you and I can have that back and forth collaboration, and we can work through all of that together. We can make the assumptions together. Sometimes we have all the loading, sometimes we don't, right? And so how do we approach that? And so I can really be, and I use the term I, right? Me, meaning my team, could be an extension of your design team. And just try to work through all of that with you. And through that process, will also help you update your specs and your drawings and your details. So it will say, 8-inch slab with whatever dosage of whatever fiber, and the specs and the details will all be totally lined up. In a perfect world, we will do an excellent job of that.
I'm thinking of a lot of situations in my head, which I'll ask these questions coming up here. But is there a good design document for someone that has no idea what they're doing here? Like example calculations that we could share on the show notes?
Yes, with a caveat. Okay, so you had asked, part of your question earlier, Zach, was about ACI or code documentation. Okay, so strictly speaking, slabs on grade are not part of non-structural slabs on grade,
Also,
are not part of ACI 318.
right. That
Right?
question's
It's
coming too.
explicitly exactly. So where do you go? What are the rules? And truth is, it's a little bit of Wild West out there with regards to slabs. You see it all. We see all sorts of it. And there are documents that speak specifically to this. So ACI 360 is a slab-on-grade design guide. It's not a code, it's a guide, but that is a resource that you can look to. It does talk about fiber reinforcement. It does talk about yield line analysis. So the things that I've mentioned are included in there. However, is there a full and comprehensive fiber reinforced design example in there? Unfortunately, not yet. I will tell you, I am involved in that committee. I go to ACI conventions every year, twice a year. So the current printed version of ACI 360 is from 2010. We're working very, very hard to print a new version, which will have great examples, but we're probably still a few years out from all of that. There's also an ACI committee based completely on fiber reinforcement. That's ACI 544. So that talks about all different kinds of fiber reinforcement. So it's not just steel fibers, but synthetic fibers, natural fibers, glass fibers, right? There's so many different materials out there for reinforcing concrete with fibers. And ACI 544 is really the go-to resource for that. So it does have some design guides, some specification guides, and so on. So if you're a member of ACI, you can get access to all those publications for free through the website, or you can pay for them, if you want to own it and print it or whatever. So there are some good resources out there, but I'll also say that if you're going to work with a specific fiber manufacturer, they will also be able to give you the guidance. So for example, we have a third-party kind of quote-unquote code evaluation document. Most people have heard of ICCES. We use a competitor of theirs called IAPMO. It basically does the exact same thing. And so we have this IAPMO report, which details all the different ways that you can use these steel fibers and how you cannot. So, for a structural application, yes, you can do this. For the punching shear example I mentioned earlier, how much strength gain can you count on and how do you calculate that? And so that's all in that document. So unfortunately, I really wish I had a better answer, for that one, but that's where we are.
All right. And I'm just thinking about all the possibilities here. Jumping to another is, I'm imagining if someone is considering using fiber reinforcing, but they're dialing into their slab. So the slab is the diaphragm. They say, well, this is a structural 318, so I cannot do fiber reinforced as well. These are different categories. Is that how this should be thought about? Or where did I go? Oh, my internet just doesn't work all the time. I was asking about diaphragms. How do we think about fiber reinforcing when we need traditional reinforcing? How does this work?
So basically, your question about diaphragm. Yeah. So we can be used in a diaphragm application for diaphragm shear resistance. So we've partnered with Nucor, who has both Verco and Volcraft composite metal decking. And for those composite slab systems, we actually do have documented strength that you can use from the steel fiber reinforcement in a slab on composite metal decking. So both Verco and Volcraft have online design tools. I know when I was in practice, I had my Volcraft catalog and I had all my flags and notes on it, and now everything is online. Okay, boomer moment over here. Yeah. But everything is online, so you can use those online tools if you do need, supplemental reinforcement for diaphragm shear. Steel fibers, specifically Dramix steel fibers, can do that. And you can actually come up with, based on the entire details of your assembly, and your factored shear demand, how much dosage you actually need. And that would almost always also satisfy your temperature and shrinkage minimum dosage as well. If you have a cast-in-place structure that you wanted to replace rebar, that is more difficult. So the only way that we're going to be comfortable doing that is with post-tensioning. So it's actually a patented system. It's called Sigma Slab, and it's Dramix steel fibers together with CCL post-tensioning. So CCL is a PT manufacturer, and this Sigma Slab system can be used in elevated PT flat plate construction to reduce congestion and rebar. And actually one of the main cost drivers in elevated PT construction is punching shear reinforcement or drop caps. And because of the punching shear improvements that I mentioned previously, that's another optimization opportunity, in addition to just, speeding up and de-risking the elevated PT execution.
When we're talking about slab-on grades, is there places where it doesn't help enough to where you do need to add reinforcing? Or is there still situations you're like, we should put a few pieces of rebar in this corner or this edge? Or
Absolutely. Yeah. Great question. So typical, good detailing practice is still going to apply. So where you would put rebar at reentrant corners or around drains or trim bars around columns, you're definitely going to keep that. So when I say that we're replacing rebar in a slab-on-grade, I'm talking about typical, those 4s at 12 everywhere, for example, or a double mat of 4s at 12, whatever the case might be. And then at areas with high stress, you're definitely going to keep some localized rebar. In addition to that, there are some systems where additional rebar does make sense. So, for example, I've done structural mat slabs for these automated storage and retrieval racking systems. So, I don't know if you guys have done any of these ASRS, rack-supported ASRS buildings. And so, the tallest one I've done was maybe 130, 140 feet. Right. And so this is a racking warehouse system where the rack is the structure of the building. So walls and roof are directly supported on the racking. So the mat slab supporting it is truly structural. And so because of that, you have to design for both wind and seismic. And at the perimeter of the slab, based on how the racking is designed, sometimes the loads, the seismic or wind loads are distributed throughout all the racks, and sometimes you have brace frames. And when your braced frames are right at the perimeter, it's really cranking a lot of uplift and moment right at the edge of the slab. So what I've done in many instances is have a fiber dosage everywhere, and then maybe just some perimeter rebar top and or possibly top and bottom, pending the loads, just to resist that. So you end up getting, the value of being able to reduce or eliminate most of the rebar and then just use it locally where you need it.
Okay, that makes sense. And then what is I'm thinking of the extremes. Like, what is the bottom end of how much you'd put in, and then what is there? There's got to be a maximum limit of where this thing is just so over reinforced with fiber.
Yeah. So everything has to be compatible with what you're doing and the concrete mix you're using it for. So, for example, the highest dosage I've ever seen was not flat work. It was this, so out in the Pacific Northwest, so close to Utah for you guys, there's a designer called Carey Kopczynski Associates, CKC, where they do a lot of mid-rise towers, very high seismic up in Washington State. And we are using 175 to 200 pounds per cubic yard of ceramic steel fibers in shear wall composite link beams.
Cool.
Now, that's a self-consolidating mix, right? You're not using, your typical execution, right? They're probably using a bucket or something to lift those up. But the findings that they did with some research that was done years and years ago was that you can really, really simplify the constructability of those elements which are normally very heavily reinforced and very congested and very challenging from a constructability standpoint, that now that goes a lot faster and easier this way. Now, 200 pounds per cubic yard is a lot. That's not typical in flooring. In flooring, the highest that I tend to do, with a type 1 steel fiber is about 60 pounds per cubic yard. And the time that I've used that is so think like in a manufacturing facility or automotive where you have a press area, 2,000, 3,000 PSF loading, 60 PCY can make sense. Generally speaking, I like to be well below that. In a typical grade supported slab, I want to be below about 44 pounds per cubic yard where I can be. But, the world is full of exceptions. So, there are different times and places. And, with the right contractor and the right mix, I can absolutely go heavier than that. It's all going to vary. Nothing is hard and fast. I talk a lot about the gray area, lots of pun intended with my concrete nerds out there, great. There's so much gray area in fiber reinforcement and in slabs on grade. So just being, adaptable and flexible about what makes sense for this project based on the stakeholders involved and what's going on.
So I have a question back on slabs, and for people that are kind of pitching this to whatever their firm or client or whatnot, the control joints, do those change at all? Like, are we longer cold joints? All the joints in the slab that they have to deal with, how do those change?
Yeah. So yes and no. Generally speaking, we still, for a typically jointed slab, we still like to follow the ACI guidelines of about 2 to 3 times the slab thickness in feet, right? So generally speaking, if you have a 6-inch slab, we would like to see control joints around 12 to 18 feet on center. That doesn't change too much. We have gone further. With typical saw cut joints. And I'm comfortable going a little bit further, but generally speaking, that's where we want to be. However, we do also do a lot of what we call jointless floors. So that's where we're eliminating saw cuts altogether and going something like 140-ish, 150 feet joint free. Now, you're still going to have construction joints, okay, because you have to stop the pour, so you have to have something, and we need to have load transfer. So I personally like to see, a fully formed, all steel kind of armored joint at those locations because your concrete's going to shrink and that joint's going to open a little bit. So you want to make sure you're protecting the edge and you have load transfer. But that's a really, really nice option, especially for more heavily loaded. If you have heavy truck traffic or, you're going to need some flexibility in your facility, that's definitely where you're going to have the longest performance and best, possible scenario for your long use of that facility. So if you were going to sell this to someone, right, it's you have to think about it like I kind of talk to people a lot about when you go out to buy a car. All right. So you say, all right, I have so much money and I want to go, I think I like this brand. I'm going to go check out the whatever. I'm not going to play favorites with car brands, but you're going to go check out the cars on the lot and talk to the salesperson and identify like what are your key priorities. And then when you're there on the lot, they might bring something up and you're like, ooh, you know what? That is compelling. It might be worth spending an extra $1,500 for that thing. Right. Or whatever, right. Fill in the blank of right. So it's the same thing, right? Dramix jointless floors are really prevalent, for example, in Europe, where, hate to say it, they're probably a good 20 years ahead of us on code adoption, fiber use.
Most things.
A lot of things, sorry. But that's the truth of where we are right now. Dramix jointless floors is kind of like the brand that's people are they just know it's like Kleenex or Band-Aid, right? A European owner might come over here and say, I want a Dramix jointless floor. That's just what they know and are used to. And it's because of, the flexibility, think about changing, you put in a facility now, but think about how much technology has changed in the last few years and how rapidly things are moving. So you want to build in a little bit of flexibility and kind of future-proofness to your facility. A jointless floor is going to really maximize that for you. So, okay, your equipment's going to change. You're going to bring in some automation, some robotics, some AGVs moving forward. That's just going to make those kinds of things a little bit easier. But for sure, you can still do it with saw cut floors. And saw cut floors are the cheapest and fastest to install. So if those are your priorities, if it's CapEx or if it's speed of execution, then a saw cut floor might still be the right choice for you. And we still see a lot of that.
When you're talking through all those things, and then the one before with the shear wall and the high mix or the high concentration of fiber, it's making me think: how does it get evenly distributed? How do you, when you pump this or you move it, all the fiber's not just at the bottom? How does it stay in the evenly distributed throughout the concrete?
Rebar seats I like seeing.
Rebar, we know exactly where it should be, at least.
I hear you. And listen, I'm a very visual person myself, so I relate to that question so much because that is one of the best things about, you go out to a job site with your tape and I specified 5s to 12 and here they are. I can see them. Yeah. It's very satisfying. Okay, so with fibers, it is a little bit different. So part of the homogeneity question does come down to how the fibers are mixed. And also it comes down to the mix itself, right? So the aggregate gradation does matter with regards to how well a fiber is going to mix, and also the amount of cement, or I should say cementitious content. So not just straight cement, but now, slag or fly ash or pozzolan, whatever else you're supplementing, because you're now increasing the surface area of reinforcement. And so you need to have enough paste to coat all of that properly. Now, all that being said, so for example, Dramix fibers that I use they actually come glued. And I was showing you guys, see, I didn't realize that I was going to need these, but I keep my little samples right next to me here. So this is the glued bundle, just a small glued bundle. I've handled these all the time, so they've broken apart. Usually they're about an inch or so wide. This one's maybe a quarter of an inch. They come glued, like little soldiers. And it's a water-soluble glue. When you add this into your wet concrete mix, this should be one of the last things added, if not the last thing added to the mix. The water in your concrete mix will break these apart, and each fiber will then break off. So at the micro level, you're getting that nice, even distribution of fibers that you're really counting on. So the glue technology is actually something that Bekaert invented some years ago, because there was previously balling, right? You would add these fibers into the concrete and they were kind of finding each other, balling up, and that was a big problem. And so this was what was developed to help mitigate that. So when the fibers are dosed properly, when you have a good mix, that is mitigated by having this glued technology. And that's since been, I think our patent has expired, so other people do that now too. So that's one step. You asked also about the fibers settling to the bottom, Max, which is, I get that, right? Because when you're picturing it, you've got all these little steel pieces in the mix and they're all just, okay. The good news is that doesn't actually happen in real life. We've done lots and lots of samples and cores and so on, and you can see that when you take a fiber reinforced concrete sample, what actually happens is, if you think about it, visualize like a three-dimensional spider web. So you've got your max aggregate and then all the other size aggregates in there, right? So you've got your 3/4 stone down to your pea gravel and your sand. It's all in there. And then you've got these, let's call it 2¼ inch long fibers. They cannot physically just fall through each other, right? In the same way that your max aggregate doesn't fall to the bottom.
Yeah.
Right? We don't expect that either. Yeah. Exactly. So with a proper mix that's well vibrated and so on, you should get a true full 3-dimensional and full depth distribution.
You mentioned a couple mix differences, but I wanted to just ask clean out, is like, are there any changes to the mix that you need to make sure you have before you specify?
Yeah. So the primary thing is the gradation of the mix. We want to see a well-graded mix, and we want to see a good percentage of fines.
Is there any like admixture, don't do this, or fly ash, right? Like everything else is kind of, like fly ash example is not going to affect this, I assume. So that one's out. But like shrinkage reducing admixtures, that for a long slab, that's fair. And what you use.
Totally fine to use an SRA. No issue with that. But I will say this. I know a little bit about concrete, but the ready mix producer knows a lot, right? They know their mix, they know their materials, and that is their wizardry. And so I want to stay in my lane. Like, I know enough to know that I want to stay out of that. So basically we have in-house, we have tools to review, okay, based on this aggregate gradation and this fiber and dosage and so on, this looks like it might be a good mix for fiber reinforcement, but we always recommend a test pour. Because as you guys know, as structural engineers know, sometimes you do something on paper that doesn't really pan out that way in the field. And it can go the other way, right? Sometimes something doesn't look good on paper, but it actually finishes great in terms of concrete. So we try to just defer to the ready mix producer and their expertise. And we might make some recommendations if we've run that calculation and it's showing that, for example, it looks like it's a really gap graded mix. We might just make comment of that, or, hey, this is looking really, really sandy. Maybe can we refine that? But the mock-up, in a test pour out in the field will really help and expose any actual issues, or if there is some troubleshooting or fine tuning that can be done, that's the best place to identify that.
If a structural engineer went out to site and saw that the concrete was acting kind of weird, when it's not mixed well, or there maybe it was a manufacturing issue, or not a manufacturing issue, but like a mix issue, what does that look like in the field?
That's a good question. The questions that we get the most are about saw cuts and about fiber exposure at the surface. Okay. So first of all, I hope that by the time that the structural consultant is coming out on the job site, if it's the real, the proper slab, placements, that some of those issues have been worked out beforehand. But, construction is the way construction is, and always game for some fun things to happen at 2:00 in the morning at a concrete placement.
Oh, yeah.
But the thing is, I think that's really important is just about management of expectations and aligning everybody on the job site, all of the stakeholders of the project as to what to expect. And so I'm going to sidestep your question for just a second, Zach, and talk about trade-offs. And then I'm going to come back to your question. So I think that, right, we as an industry have come to understand rebar really, really well, but it has trade-offs, right? When you use rebar, it has to be chaired properly. There's labor associated with tying and chairing rebar. There's safety risks associated with doing that. And because you have cover required by code, you have at least, let's say, an inch or so of concrete above, unreinforced concrete above your top layer of rebar. That means that's kind of vulnerable. So in a manufacturing or heavy duty slab environment, you might have some durability issues, right? Some damage, some spalling. Rust can be an issue. I'm sure we'll talk more about rust. That's always another question that comes up with steel fiber reinforcing. But we've all just kind of come to accept that that's the gold standard is rebar. But if we think about those trade-offs and then we say, okay, now knowing that when you use a fiber reinforced solution, it's going to be faster to execute and safer to execute. You're going to have performance improvements. It's going to be much more durable and long lasting. But because it is a three-dimensional reinforcing, you could have fibers visible at the surface. Is that acceptable? Right. And maybe the owner says yes, and maybe the owner says no, right? They may or may not be willing to live with that. And that's okay, right? I think it's just about having these conversations openly and transparently so that everybody understands. And so now coming back to your question, Zach, if an engineer comes out to the site and they're seeing obvious balling, right? The fibers are balling up, you've got footballs coming out of the truck. Okay, that's a problem on mixing, right? So we need to address that. But if they're just seeing it's going down and maybe there's some fiber visibility at the surface, but generally speaking, things are going well, then that's not really a problem, right? You should actually expect to see some fibers at the surface. Now, we do a lot to try to limit fiber visibility, right? Through the mixed design review, through coordination and certification of the flooring contractors and so on. But it's actually not a bad thing, right? That's telling you that your fibers are full dimensional or three-dimensional, top to bottom in your mix. That's proving that you're getting the reinforcing that you're counting on. Did I kind of answer your question? I hope I answered your question.
I've been thinking about, but we started on the A and B project.
Yes.
I would love to actually go back and once these are poured, what was the outcome of this? Like time to pour, the final appearance, performance. Can we touch back on that one and see how it landed?
Yeah. So when it started, to be honest with you, I felt like everyone was a little bit holding their breath. We're all like what's going to happen?
It's like a test. It's
100%. And what ended up happening was after a few weeks of slabs going down and going well, and the speed being really impressive, what actually happened was I got called into 4 additional products by those stakeholders on those projects. I got called into 4 different projects within 2 weeks.
Oh my gosh. So
they were like, oh, this is good. Oh. So then it was another one with the GC, another one with the flooring contractor, and 2 additional ones with the owner. They're like, this owner told us to call you. And so here we are, right? So it actually really worked. Luckily, we were able to deliver what they had promised and what they were counting on.
Wow. Was there like from a testing standpoint, is there more or is there additional testing required of the concrete itself when you're pouring cylinders or anything like that when you're using fiber?
Yeah. So yes and no. Strictly speaking, no. Right. So when you do a project with us, I'm going to advocate really, really strongly that the fiber manufacturer be on your pre-pour calls together with the structural engineer and the GC and so on, so that we can make sure to clear up any of those types of questions. So for example, with cylinder testing, it depends on when they're pulling cylinders. So if you're pulling cylinders before the fibers are added, nothing changes, right? We're not changing compressive strength. Doesn't really matter. But about half the time, I would say the cylinders will be placed at, the cylinders will be sampled at point of placement, which will already have fibers in which case we would say use a larger cylinder size. So we want to see a 6-inch by 12-inch cylinder. The main reason for that is we have these 2.25-inch long fibers that are going in. And if the cylinder is so small, the main challenge would be that you basically don't vibrate it enough and you get a void, and that skews your sample results. So we just say use a larger sample, vibrate it really well using the normal, typical industry practice. And, you should expect your compression results to come back exactly the same. There are a couple of times where somebody has asked to do project-specific beam testing. It's very few and far between. I'm coming up on 7 years in this role. I think maybe just less than a handful of times that I've had project-specific beam testing, but that's at the discretion of the owner or the team on the project. If they choose to do that, that's an option. It just adds a little bit of time, right? Because then you have to cast the samples, wait 28 days, do the testing before anything else can happen.
And that's the flexural strength of the
Correct.
of the concrete is what you're saying. Yeah,
that's right. Post-crack flexural strength. That's right.
Can I ask a question that you brought up the word earlier, rust? Is that, does that occur? What's the, what do we do to prevent if needed? We have steel much closer to the surface. If we need to protect the steel, we'd like it low down in the concrete. And then, we talked before that I do a lot of industrial right now. And if we're doing a product that's right on the ocean, I'm doing today a pier that's on the ocean to support some conveyor. Could it fit into that space ever?
Yeah, definitely. So also one of the top questions that I receive. So first of all, let's talk about your project later, Max, because yes, we can absolutely use fiber reinforcement in that type of application. In fact, my team has provided like port terminal, those big shipping port pavement slabs all over the world, let's say 10 million square feet a pop with uncoated ceramic steel fibers. And it's because of the things that we talked about earlier, right? The crack control, the durability, the long-term performance is all actually enhanced when you use this type of reinforcement approach. But again, management of expectations has to be discussed, because if you have a fiber close to the surface and some type of corrosive element is there, that fiber could rust, right? This is just carbon steel. That can happen. Now, what is the risk associated with that? That's the real question. And it's actually very limited to aesthetics.
Okay.
So what happens is that these fibers so the ones that we use most often are less than 1 millimeter in diameter. They're really, really skinny. And so if you think about the typical damage that you see from rust, right? When you're driving up under a bridge and you see that spalled out section. So spalling is actually an expansive pressure of rebar. It's when it corrodes, it expands, and that pops out the concrete around it. But with steel fiber reinforcement, the fibers are so small that they don't generate enough expansive pressure to cause any damage. That's one part.
Within the strength compatibility of the concrete to push a little bit, but it's so small that Nothing will happen.
It literally doesn't cause any
That's
true
cool.
structural damage. But there's multiple layers to this. The other part is fiber reinforcement is generally well known for what, right? It's crack control. So because you have this network with hundreds of thousands of fibers holding cracks really, really tight, even ACI 360 indicates that the depth through which corrosive elements can penetrate into fiber reinforced concrete is usually limited to about 1/10 of an inch. So you're limiting the permeability
Yeah.
of this section. So that's 2. And then the third thing is that these steel fibers are discontinuous. So because the fiber network is not touching, right, each of these fibers are just hanging out in the matrix, even if a fiber corrodes, it's not going to spread that corrosion to any of its neighbors. So because of these 3 components, let's say, it's actually a really strong solution in a highly corrosive environment. Now, is it the right solution in every corrosive environment? I don't know, right? That has to be evaluated. But I have yet to be involved in a project where they said, you know what, I really just can't. Well, I take that back. There's probably been a couple of conditions where they said we can't have any steel in the slab because of A, B, or C reason. Sure, right? We can go to a synthetic fiber, which we have, no problem. Or I've also offered a galvanized steel solution in a couple of instances. So Bekaert is a really interesting company. We make steel things and coatings predominantly, right? Those are our 2 biggest strengths. Bekaert makes a hot dip galvanized coating, and we make these steel fibers. So then we were like, hey, you know what we could do? However, I have to tell you guys, we sell very little galvanized steel fibers because it's really an added cost with a short-term benefit, because probably after, I don't know, 5-10 years, that galvanization is going to wear off. And so it's just really postponing that. So in some aesthetically sensitive instances, I have used a galvanized solution, but predominantly, even in a port terminal like we were talking about, I would actually just use an uncoated steel fiber.
You've brought up synthetics a few times. Is there a common place where one makes more sense than the other one?
Yeah. So historically, Bekaert has been a steel fiber reinforced company, right? We invented Dramix over 40 years ago. This is a long-standing technology that we've been using, but synthetics have been around for a really long time, and they definitely have their place in the market. So usually where we're seeing a great application of a synthetic, and when I'm talking about a synthetic, what I'm really meaning is a macro synthetic fiber. There are also micro synthetic fibers, which are, as the name implies, much smaller, and they have a different use. I'll come back to that. But with macros, it's usually like a lightly loaded scenario. Lightly loaded, lightly reinforced. So let's say you have a 6-inch slab with 3s at 18. That's probably a great fit for a synthetic macro fiber. Okay. When you are in the 3, 4, 5 pound range of macros, that tends to be really cost effective and work really, really well. I've seen dosages in the 7, 7.5, 8, 10 pound range. So if you think about what a synthetic macro fiber is, right, it's a polypropylene or polyethylene or different types of synthetic material. But by and large, right, these things just don't weigh that much. So 4 pounds is a good amount, but 8 pounds is a lot of fibers. And when you start adding that to a concrete mix, talk about surface area, talk about water demand, talk about fines, right, that really does start to have implications. And so there are chemicals that can handle that, right? Use a water reducer, plasticizer, right? And those are things that will also be applicable in some steel fiber mixes as well. But generally what we've seen is that when you're above about 6 pounds per cubic yard of a synthetic macro fiber, that using a high performance steel fiber is going to be easier to work with and finish and have a better overall installed cost.
Okay. Yeah, that makes sense.
That's the cheat sheet for the day. Jot that down. Over 6 pounds, go to a high performance steel fiber.
Easy.
So what other questions do you commonly get? It would be good for us to know that we've not asked yet.
Ooh, yes. So the one that I hear the most is people are like, oh, well, this is just for temperature and shrinkage, right?
Yeah.
Which No, it was not.
I failed the test. Dang it.
No, so and that's the thing, right? Is that it's just so difficult to find this information, or rather, you guys are busy. Structural engineers are busy, right? You've got your billable hours you have to do. P.S. I don't miss that one bit. Just saying. But it's not like readily available, and you're not just out there doing research about materials. So I totally get it. But temperature and shrinkage is something that we can provide with both steel or the synthetic fibers. And again, macros.
Yeah.
The primary benefit that you're going to get, though, is when you use a high performance steel fiber for strength. Okay, so with that, we can resist the loads and sometimes even optimize the slab thickness, right? And here's the thing. I have a master's degree in structural engineering. I don't think I ever learned how to design a slab on grade in school. Max is laughing because
No, yeah.
right? So if you're lucky enough to work at a firm that has some in-house experience with industrial and they can teach you how to design a slab, then you're in the fortunate few, honestly, because it's not that commonplace. Even when I worked at Walter P. Moore, I don't think I ever designed a slab on grade, or there was just a standard detail. Hey, we're doing, multifamily residential. Hey, we're doing education, whatever it is, just put in this, right? Exactly. Copy paste. I understand why people do that, but now all I do is slabs on grade, it seems like. Okay, so I am nerded out completely, and I can go and talk until you're blue in the face about what type of joint to use, what thickness of slip sheet. Do we need a slip sheet? What about, is it a vapor barrier or is it a slip? All these different things that, you guys as structural engineers, you have to think about the whole structure. If you can allow someone like me to help support you, because all we do is focus on slabs and flat work, that's just an asset that we can bring. So coming back to my question about, okay, well, if you've just done a copy and paste and you're just putting in an 8-inch slab with something, because that's maybe what you've done before, that's an opportunity to perhaps bring some value to a project with a slightly more thoughtful design that's really taking into account the loading scenarios, the jointing, and what we think will provide the biggest value to the project. It's not always just temperature and shrinkage. Now, there are some fibers that do only do temperature and shrinkage, and that's the risk here, is that there isn't consensus. And that's what makes this hard, to be honest, is I feel like, engineers like it when it's easy and straightforward because what you're doing is already very complex. And unfortunately, that's not always the case with fiber reinforcement because there are people saying different things in the industry. So I just say, talk to the person with a fiber manufacturer and see if they understand what they're talking about. Do they understand engineering principles? Do they have a background in engineering? Do they understand how things are built? And if you really feel like you can trust them, then, listen to them. And if you don't, then call me.
Yeah. We'll put all of her information is down in the show notes.
Oh God, I'm going to have to put my phone on Do Not Disturb.
Well, Claire, thank you so much for sharing all of your knowledge with fiber reinforced concrete. I learned a lot. I started this thing, I knew some stuff, but my mind has been blown. So thank you so much.
It's been a pleasure. For whatever it's worth, I have been here years now, and I'm still learning things too,
Perfect.
both about fiber reinforcement and about slabs. This is a really complex and nuanced subject. So, just continue learning. And thank you so much for having me. This has been a blast.